Out there, far beyond Mars and the quiet belt of icy rocks, the weather becomes violent in a way that almost feels alive. On Jupiter, storms wider than Earth have been raging since before telescopes existed. On Neptune, winds scream across the deep blue atmosphere at nearly 2,000 kilometers per hour, faster than any hurricane our planet could survive. Here is the question: how can the coldest, darkest worlds in our solar system have the most extreme winds? Today, we are going to read the weather of the giants, from Jupiter to Neptune, and find out what is really driving that chaos. Jupiter is not calm. When you look at it, those pale and rusty bands wrapping around the planet are not decoration. They are rivers of gas, racing in opposite directions at hundreds of kilometers per hour, endlessly tearing and folding into each other. The Great Red Spot, that huge oval scar, is a high-pressure storm wider than Earth that has been raging for at least 3 centuries. No human city, no empire, no country has lasted that long without changing, but this storm is still here. On Jupiter, storms do not quietly die. They adapt, merge, feed, and keep going. Why is it so violent? Part of the answer is speed. Jupiter spins incredibly fast. One full day, there is only about 10 hours long. That rapid rotation twists the atmosphere with extreme Coriolis force and breaks it into bands, what scientists call jet streams. These jets are like conveyor belts of wind that wrap the whole planet. Where 2 of these bands slide past each other in opposite directions, the shear between them becomes brutal. It rolls the gas into vortices the size of continents. You can almost watch the planet kneading its own weather. But there is another fuel source, and this is where Jupiter stops behaving like a normal planet. Jupiter gives off more heat than it gets from the sun. Deep inside, the planet is still hot, still contracting, still leaking energy left over from its formation. That trapped heat rises. Warm gas pushes upward, cooler gas sinks downward, and that constant vertical motion pumps energy into the upper atmosphere. Think of boiling water, but scaled up to a world so large you could fit all the other planets inside it except Saturn. The result is permanent turbulence. From a distance, Jupiter looks chaotic. Up close, it is organized chaos. Each bright zone and dark belt is part of a layered system, a stack of winds flowing east, then west, then east again, like alternating lanes on a superhighway that never ends. The edges of those lanes are where the violence lives. That is where small storms are born, and where small storms sometimes grow into monsters. Jupiter is not weather. Jupiter is a weather machine. And this is only the first act. Because if Jupiter is constant fury, Saturn is something else. Saturn pretends to be gentle. Soft gold clouds, elegant rings, graceful symmetry. But beneath that calm, Saturn holds pressure and then releases it in world-scale outbreaks that can wrap the entire planet. Saturn does not rage all the time. Saturn saves it up and then explodes. Saturn tries to trick you. At first glance, it looks calm, almost gentle. The planet wears soft bands of cream and gold instead of the violent rust and white stripes of Jupiter. It is framed by those perfect rings, so thin and bright that the whole world feels delicate, almost peaceful. But that is an illusion. Near the equator, winds on Saturn can whip around the planet at more than 1,700 kilometers per hour, in some places even faster than the winds on Jupiter. Under the pretty surface, the air is racing like a blade. And then there is the hexagon. At Saturn's north pole, the clouds arrange themselves into a giant six-sided structure, a geometric storm larger than Earth. It is not a drawing. It is not an editing trick. It is a standing jet stream, a ring of roaring wind that has locked itself into a perfect polygon and refuses to break. The shape holds because different bands of air are moving at different speeds, wrapping around each other in a way that stabilizes the corners. No other planet we have ever seen does this. On Saturn, the weather can do math. But Saturn has another kind of violence, and it comes in pulses. Every few decades, the planet erupts with what astronomers call a great white spot. A storm so bright and so wide that for a while, it can wrap around most of a hemisphere. It boils up from deep inside, explodes into the upper clouds, and can last for months. You could point a telescope from Earth and watch that wound, that pale blast of energy, spreading across the planet like a scar that keeps growing. Saturn is quiet, 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 and then it screams. The engine behind all this is buried within. Like Jupiter, Saturn is leaking heat from its interior. It glows in the infrared with more energy than it receives from the sun. That trapped heat rises, feeding the jet streams and loading the atmosphere with tension. Add to that a day that lasts only about 10.5 hours. The planet spins so fast that the Coriolis force carves the atmosphere into lanes of wind, racing in opposite directions, storing stress the way a fault line stores tectonic stress. Saturn is beautiful, yes. But it is beautiful in the way a pressurized tank is beautiful. If Jupiter is non-stop rage, Saturn is the heartbeat of a predator. It waits, it gathers strength, and then it strikes the entire world at once. And yet, what comes next might be even stranger. Because the next planet does not just have violent weather. The next planet is tilted almost on its side, and its winds race around a world that rolls like a wounded animal. That planet is Uranus. Uranus should not spin the way it spins. Most planets turn like tops, more or less upright. Uranus is different. It is tilted almost 90 degrees, as if someone knocked it onto its side long ago and it never stood back up. Because of that tilt, its poles take turns staring directly at the sun for years, then dropping into deep darkness for years. On Uranus, a season is not a few months. A season can last for decades. Light and night come in eras. With lighting that extreme, you would expect chaos. You would expect a sky ripped by storms, constant boiling, violent changes as one pole cooks under sunlight while the other freezes in shadow. But that is not what we see. For long stretches of time, Uranus looks strangely quiet, almost featureless. Soft blue-green, smooth, plain, almost sleepy. No permanent storm like the Great Red Spot. No giant planet-wide eruption like Saturn. It does not look angry. It looks bored. That is the mystery. Because the calm is only skin deep. High in the atmosphere, Uranus still drives fast jet streams. Winds can reach 800 to 900 kilometers per hour, depending on latitude, racing around the planet sideways. Thin bands of methane clouds drift and shear, sometimes brightening for a moment, where rising gas punches upward. You are watching a world roll through space like a barrel, with its air sliding around its belly in long, cold rivers of speed. Here is the strange part. Jupiter and Saturn get a lot of their weather power from within. They leak heat from their hot interiors, and that internal heat keeps the atmosphere churning. Uranus does not. As far as we can tell, Uranus gives off almost no extra heat. It seems quiet inside, maybe because it lost energy in some ancient impact that tilted it in the first place. So you are left with a question that should not make sense. If the engine inside is weak, why are the winds still so strong? This is where the story turns. Uranus is tilted, pale, and unsettling. But the next planet, Neptune, takes all of this and pushes it to the edge. Neptune is about the same size. It lives even deeper in the dark. It is brutally cold. And yet its winds are not just fast. They are the fastest sustained winds in the entire solar system. Neptune is what happens when the weather stops pretending to be gentle. Neptune should be slow. It lives in deep darkness, so far from the sun that it receives only a tiny fraction of the light and warmth that reaches Earth. The air at the top of its clouds is colder than -200 degrees Celsius. By common sense, this world should be quiet, frozen, almost motionless. But common sense does not survive on Neptune, because Neptune is not quiet. Neptune is violent. Winds there can roar at speeds near 2,000 kilometers per hour. Enormous dark storms form like bruises on its blue atmosphere, drift across the planet, and then vanish within a few years. Each of these storms can be bigger than a continent on Earth. On our planet, we name hurricanes. On Neptune, you would have to name the whole sky. Where does that power come from in a place so cold? The answer is that Neptune is heated from within. Just like Jupiter and Saturn, Neptune gives off more energy than it gets from the sun. The inside is still warm, still pushing upward. That rising heat meets the brutally cold outer layers and creates a huge difference in temperature. That difference drives convection, and that convection drives wind. It is like watching a pot boil, except the pot is a planet made of ice blue gas. There is one more trick. A day on Neptune lasts only about 16 hours. The whole planet spins fast, and that fast spin twists the atmosphere with intense Coriolis force. The result is powerful jet streams that can stay coherent instead of ripping themselves apart. On Neptune, extreme wind is not a rare emergency. It is simply the weather. And now that we have seen Jupiter, Saturn, Uranus, and Neptune, we can read something else. Wind is not just air in motion. Wind is memory. It tells the story of what each world has been doing for billions of years. When you listen to the winds of these giant planets, you are not just listening to weather. You are listening to memory. The speed of the jet streams, the way storms form and fade, even the places where the air tears itself apart, all of that tells scientists how fast a planet spins, how hot it is inside, and whether it has been struck, wounded, or reshaped in the past. Wind is a record carved into air. This matters for more than curiosity. We are now studying planets around other stars that we cannot touch and cannot even see as disks. All we get is a faint signal. To understand them, we practice here. By decoding Jupiter, Saturn, Uranus, and Neptune, we learn how to read climate on worlds we will never visit. The outer giants are ancient engines still running after billions of years. We are a fragile species on one small rocky world, and yet we can hear their breath. That breath is the wind.